SAE J211, if you're doing any kind of dynamic testing, SAE J211 is a wealth of technical information and detail you need to be aware of. Keep watching for more details. Hi, I'm Mike Beckage, co-founder of DTS, and today's topic is SAE J211. SAE J211 has a wealth of information regarding testing practices, sensors, data acquisition, and even software processing that help you get the most out of your data collection equipment in a wide variety of applications such as automotive, aerospace, and even general testing applications. So what is SAE J211? Well, it's one of a number of recommended practices and standards created by the Society of Automotive Engineers. The Society of Automotive Engineers is actually a group of volunteers from a wide range of industries that get together in committees. The purpose of the committees is to provide guidance to test engineers worldwide so that data are collected in a consistent manner, thus making comparison between different test sites possible. SAE J211 focuses on instrumentation for impact testing, but it has very broad application in any application where you're taking high-quality measurements. In certain parts of the world, there is a corresponding document called ISO 6487. It is a document published by the International Standards Organization, and the committees that write both of these documents work very hard to try to keep the two harmonized. SAE J211 is managed by the Instrumentation Standards Committee of the Society of Automotive Engineers. It has two parts. Part 1 is called electronic instrumentation, and Part 2 is called photographic instrumentation. For this video, we will focus on Part 1, electronic instrumentation. Within SAE J211 Part 1, there are really two categories of requirements that you need to be aware of. First are things that the data acquisition system and sensor manufacturer needs to be aware of in order to build a system that works in the application. The second is really a list of things that the user needs to be aware of in order to properly set up and use the system. It's important to note that all of these requirements refer to what's called the whole data channel. This includes everything in the signal chain from whatever sensors you're using, through the cabling, to the data acquisition system, and the post-processing software, including things like the filters that are used and any injury calculations. Some of the items that the user really doesn't have much control over, but we as data acquisition system providers must be aware of, are things like the number of bits in the ADC system, how fast the system can sample, how we implement the software filters, and timing alignment. SAE J211 Part 1 includes a number of specific sections, each of which contains critical information for applying a data acquisition system in virtually any kind of testing environment. Sections 1 and 2 generally address the scope and applicability of the recommended practice. But I'm going to start with focusing on Section 3, which is actually entitled Definitions. There's a lot of good reading there and basic information that you should at least be familiar with. Section 4 is entitled Data Channel Performance Recommendations. And this section actually contains a lot of very specific information that we as a DAS manufacturer and a sensor manufacturer and anybody working in this realm of test and measurement needs to be aware of. A lot of things contained in Section 4 drive the designs that we deliver to the market. Part of Section 4 defines channel frequency classes, which are basically amplitude versus frequency response curves for a number of different frequency ranges. In Section 5, Data Channel Selection, we learn what channel frequency classes should be applied to different measurement locations or measurement types. Section 6 is a very brief portion of SAE J211 Part 1, and it focuses on sensor mounting considerations and also introduces the topic of transducer resonance. Section 7 is entitled Sign Conventions. But what does that really mean? Well, any measurement you take will have an active axis For example, with this angular rate sensor, its active axis is perpendicular to the mounting flange. So number one, if I mount that sensor in this axis, I need to have it properly labeled. Second, it will have a polarity. If I rotate it one way or the other, it'll give me a plus or a minus output. It's important that all measurements follow a consistent sign convention, and SAE J211 Section 7 helps us accomplish that goal. Section 8 is entitled Digital Data Processing, and this is really where the rubber meets the road, so to speak. We have requirements for minimum sampling rate, filtering that's applied to avoid aliasing, the number of bits that the system must have, and even how you implement the software post-processing. There are a couple of other sections in SAE J211 Part 1, but for this conversation, I've focused on the ones that are of critical importance for you to be intimately familiar with. Sections 9 and 10 contain requirements for time alignment between data channels and also event marking. Our systems by design meet these requirements. Sections 11 and 12 contain very general requirements for data presentation. I want to call your attention to the fact that there are a number of appendices in SAE J211 Part 1. Two in particular that are of great importance are Section D, which has to do with grounding practices, and Appendix E, which talks in very great detail about avoiding the pitfalls that can result from not properly handling transducer resonance in your data acquisition setup. I hope this information was helpful. For more information, you can always go to the SAE website and purchase the latest copy of SAE J211 Part 1 or even Part 2 for photographic instrumentation. And we have lots of information on the DTS website and Help Center. Happy testing!